right, we're going to do 10-4A today. We are halfway through with our conic sections. We've learned 2 of them, and we have 2 more to go. So we're going to focus on ellipses today. Ellipses. So far we've done circles and parabolas, and I think circles have been your favorite. And they'll probably stay that way because ellipses have a lot of pieces and information to them also. Okay, so what makes an ellipse? Well, let's go ahead and do a little introduction into what an ellipse is. An ellipse is an oval. It's an oval shape. So it's taking our cone, our 3-dimensional cone that I showed you in class. It's taking that and it's taking a slice out of it going this way. And what happens is when you do that and you go that way, you get an oval shape. See that oval shape there? If you took a slice right out of this cone, you'd get an oval shape, and that's called an ellipse. And the way that you make an ellipse is it has a center, but that's not the important part. The important part are these 2 points right here. And those 2 points are called the foci. Foci is plural for focus points. So if you have 2 focus, you wouldn't say focuses, you would say foci. And it's not foci, it's foci. And these foci are fixed points. And you're like, why are those so important? Well, this is what's important about this. If you choose any point on this parabola and you found the distance from this point to that point and you added those lines up, it would be that way, any point on here. So if I went, say, way over to this point and I drew a line here and a line there. Ooh, maybe it's the subtraction. Shoot, do I have to start over? No, it's the sum, but that doesn't look very good. My ellipse is not very good here, but it is. It's the sum of these 2. It's going to be the same all the way around. Yeah, that looks really bad. So that's not a very good ellipse, I guess. The ellipse should be more circular, or not circular, but more oval than that. Okay, so let's go ahead and I'll give you the equations that you need for ellipses. So an ellipse, the book kind of talks about 2 different equations, but I like to just give you 1 equation. I think it kind of, confuses people when you give them 2. So the equations for ellipse looks like this. It's going to be x squared over a squared plus y squared over b squared equals 1. So that's the equation of an ellipse. Okay? And this is the equation of ellipse when it is centered at the origin. Center is going to be at 0, 0. We will change it to HK later on in this chapter, but for 10-4A and B, we're just going to have it centered at the origin and make it easier on you because these are tough. All right, so here's what happens. We get 2 types of ellipses. So we have 1 equation, but we'll have 2 types. So here are the 2 types. When A is bigger than B, your ellipse is going to be longer horizontally. So let me show you how to graph these. So what you do is we're centered at the origin, and you will go a distance of A in that direction and a distance of A in that direction. Because, that's a little off, because A is the number underneath X. See up here, X, and we have A. So A is there, and then B is going to go, it's going to be smaller because I've said that A is greater than B. So B would be up and down, a distance of B. And the way that you make this ellipse is to put dots on all of those points, and then you draw an ellipse around like that. It looks kind of like a football. There you go. Okay? All right, when A is less than B over here, you're still going to graph it the same way as you would go A in each direction on the X. but B is going to be farther away because B is bigger than A. And so what you get is you'll still get an ellipse, a distance of A left and right, and a distance of B up and down, but it's going to be longer up and down than it is side to side. Okay? All right, so let's talk about these pieces, these parts. I already told you, well, that the center is at 0, 0, okay? And that's true for both graphs. Center is at 0, 0 over here too. And then these points are going to be kind of special. So if you have, if A is bigger than B, then your vertices, we're going to have something called vertices and co-vertices. Okay? And the vertices are going to be the ones that are farther away from the center. So our vertices for this graph up here would be at plus or minus A, comma 0. Okay? So those are the vertices. And then the co-vertices would be at 0 plus or minus B, because they're not as far away. So like being like a co-champion is not as great as being like the champion. So they're co-vertices. Over here, they just get switched. Because B is bigger than A, because this is farther away from our center, our vertices are the bigger ones. And in this case, they're at 0 plus or minus B. And then the co-vertices, I'm just going to abbreviate it as covert. Co-vertices are at plus or minus A, comma 0. Okay? Excuse me. Now, over here on this side, we have two other things. We have a major axis and we have a minor axis. Which one do you think's bigger? Yep, the major axis is the bigger axis. And the major axis is going to be from here to there. It's the length of that distance. And do you know what the length of that distance is? Well, if I go a distance of A that way and a distance of A that way, then the total length is 2A. And then over here, if I go up and down a distance of B and B, but a shorter distance, its minor axis is 2B. Or not 2B. Just kidding. Okay, so there you go. Now, on the other side of this line, over here, the major axis is now longer going up and down. And so the major axis is 2B, and then the minor axis is the shorter one, which goes side to side, in this case is 2A. So just remember that minor is shorter and major is longer, okay? All right, what else do we have? What else do we have? Oh, last thing. We need to find out, we need to figure out how to find the foci, okay? Now this is going to be a very important part. The foci are always going to be on the major axis, always, okay? So the foci are either going to be here, there's two of them, there and there, or they will be somewhere here and here. And how do we find the foci? Well, the foci are going to be a distance of C from the center, okay? So we'll write that down. From the center to the foci is equal to C. That's very important. So this distance here and here is equal to C. Same thing up here, that's C also. Now, the important thing is how are we going to find C? Do you remember parabolas? We found C by doing A equals 1 over 4C. Okay, this is going to be a little different here. So to find the foci, up here you would do C squared equals A squared minus B squared. Okay? So you always take the bigger number minus the smaller number, and then you'll get what C squared is. And so the foci would be at plus or minus C, 0. Now, if we're over here on the green side of this stuff over here, and you do c squared would equal b squared minus a squared. And I know you feel like, oh my gosh, there's so many things to memorize. It's always just bigger minus smaller. Okay, so you don't need to remember if is it a squared minus b squared or b squared minus a squared. It's just the bigger number minus the smaller number. And in this case, your foci would be at 0 plus or minus c. And that's how you find them. Okay, so let's do some examples. Let's do some. I'm going to start you with graphing these first. The book doesn't really start that way, but I want you to visually see what's going on here, okay? So let's go ahead and let's do some graphs, okay? And you remember I told you that there's two parts to this. There's like, you find the equation given some pieces, or here's the equation and you find the pieces. All right, so let's go ahead and graph some. Number one. Let's start off with x squared over 9 plus y squared over 25 is equal to 1. All right, so here we go. We're going to graph this. I'm going to show you how to graph an ellipse. And then we're going to find a whole bunch of things, okay? We're going to find out what the vertices are. We're going to find out what the co-vertices are. So these problems, a lot of times they won't ask you for all of this stuff, but it's good to do it. You will have to do it on a test or quiz. You'll have to find all these things. We're going to find the major axis length. We're going to find the minor axis length. And these won't be too hard. And then finally, the last thing we're going to find are the foci. That's going to be the trickiest part of all. We'll save that for last. Okay. So the center, of course, is at 0, 0. And I say that, of course, because right now it's just always going to be at 0, 0 until we get to lesson 10, 6 at the end of the chapter. So right now, 0, 0. Okay, so if you take a look, we're looking at this right here, this x squared over 9. Okay, so I'm going to go a distance of 3 because I want to do x, which is squared, and 9 is 3 squared. So I go a distance of 3 in each direction. And I plot that point. Okay, now I'm going to look over at the y. The y is y squared over 25. So let's take the square root, and we're going to go a distance of 5 from the center up and down. And we're going to plot our points there. Okay, once you have those points all plotted, you can go ahead and draw your ellipse. It's going to look like an oval shape, okay? So let's talk about vertices and co-vertices. The vertices are going to be the points that are the farthest away from the center. And what are those points? That's the point 0, 5, and that's the point 0, negative 5. And we can write that like this, 0 plus or minus 5. The co-vertices are the shorter distance away from the center. And that point would be right here at 1, 2, 3, 0, 1, 2, negative 3, 0. So we can write it like this. Okay? Now, the major axis length is going to be the length of the longest side. And so this length is 5 here and 5 there, which makes a total of 10. And you know, I gave you that formula, you know, like the major axis length is 2b. You don't have to memorize that. Just look at your graph and go, okay, how long is that? Oh, it's 10. And then the minor axis length is across this way. 3 plus 3 is 6. Okay. Now we're ready for the foci. The foci are going to land somewhere on the major axis, somewhere around here or here, not quite sure. Here's how you find the foci. You're going to do c squared equals, because c is this distance. I want to find out how far that is. C squared equals. Now, here's where you get confused. What is it? A squared minus b squared? Is it b squared minus a squared? Just think it's going to be the bigger number, which is 25, minus the smaller number, which is 9. Okay? And when you do that, you will get c squared equals 16. So c would be plus or minus 4. Now, it is plus or minus 4 because, well, C is really a distance. It should just be positive 4, but it's okay. We're going to go 4 in each direction, up and down, because they are on the major axis. And if I went up and down a distance of 4, my foci would be at 0 plus or minus 4. And that's all the parts. Okay? All right, let's do another one. If you don't need another one, you can fast forward, but I'm going to do another one going the other direction. So it's going to be longer going side to side. And our foci aren't going to turn out as nice this time. That's okay. All right, so let's go x squared over 100 plus y squared over 16 equals 1. Now, when I have you graph these or I ask you for these parts, I like to give you perfect squares so that you can graph it nice and easily, okay? So let's go ahead. We're going to find the vertices, the co-vertices, the major axis length, the minor axis length, and last, and kind of least because it's the hardest and our least favorite, is to do the foci. Okay, so here we go. Start with x right here. We have x squared over 100. We're going to start with that. And we're going to go a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in each direction. Okay? 10 in each direction. So this is going to be a really long one. All right, and then we're going to go a distance of 4 in each direction, up and down. Because that's the square root of 16. Perfect. All right, so I have my 4 points that I need, and let's go ahead and graph our ellipse, kind of. There you go. Hopefully yours is better than mine. I don't really graph these very well. There we go. Okay, so our vertices, remember, are going to be the ones that are the farthest away from the center. And so that would be right there. Those are on the x-axis, and those points have coordinates plus or minus 10, 0. The co-vertices are going to be the shorter nobody wants to be a co-champ, and that would be at 0 plus or minus 4. Okay. The major axis length is 10 plus another 10. There's 10 there and there's 10 there, which gives us a total of 20. And the minor is up and down 4, so that would be a length of 8. All right, the foci, here we go. C squared equals big number minus small number. Okay, you do not need to memorize a squared minus b squared or b squared minus a squared. You just need to know that you subtract the big number minus the small number. And so we get c squared equals 84. Now, when you take the plus and minus square root of this, you get the plus and minus square root of 84. And I don't know if you remember, but we're not supposed to leave that because there is a perfect square in 84, and that perfect square is 4 times 21. So this is really plus or minus 2 rad 21. Now, are those ugly points? Yes. That's okay, though. All right, so that means from the center, our foci go a distance of plus or minus 2 rad 21 in each direction. We have to list the foci as points. They need an x, and they also need a y. My last problem, you see the foci went in the y spot because it was longer going up and down. My foci here goes in the x coordinate spot because it's longer side to side. The foci will always be on the longer axis, and the longer axis is going to be x because it's the bigger number here. Whew. Okay. Now, let's go to part C. How many parts are there? This is it. Last part. Okay? So, now I'm going to give you, and we're going to have to come up with an equation. I'm going to give you some parts, and you have to tell me what the equation is. Now, the equation, all ellipses are going to look like this. Okay? Over b squared equals 1. This is what we're trying to get, this right here, where we have to find out what a squared and b squared are. So here we go, number 3. All right, so they'll tell you the vertex, one of the vertices is at 0, 5. And then they'll tell you that a co-vertex, one of the co-vertices, is at 2, 0. And then they also tell you that the center is at 0, 0, which we already know because that's where we're keeping it for right now. And we want to come up with an equation of the ellipse. What's the equation of the ellipse? Okay, you can draw a picture if you're a visual person, you want to see what's happening. You can plot these 2 points here and here. So plot 0, 5, and you're up here. 1, 2, 3, 4, 5. And then plot 2, 0, and you're here. Okay? And your ellipse would look something like that, but better. All right, so here we go. X squared over something plus y squared over something equals 1. And what are these somethings? Well, from here to here is a, and that's 2. So 2 squared is 4. And from here to here is a distance of 5. And underneath y squared would go 5 squared, which is 25. And that's it. That's the equation of the ellipse. Okay? Like, sweet. This is easy. It is a little bit right now. It'll get a little harder on the next one that we do. Okay? Let me give you another one, number 4. Suppose that the center is 0, 0. You knew that was coming. And let's say that the height of the ellipse is 18 and that the length of the ellipse is 12. We want to find an equation, write an equation of this ellipse. All right, so if you want to, you can draw a picture of this again. Center's at the origin. The height is 18. What that means is this entire thing is 18, okay? And the length is 12. This entire thing is 12. They could have also said the major axis is 18 and the minor axis is 12, okay? Now, what that is I'm going to go x squared over something plus y squared over something equals 1. So if this has a total length of 18, that means that I would go 9 in each direction because that's half of 18 is 9. It would be 9 and 9 make 18. And that's going up and down. And which axis goes up and down? The y-axis. So B is 9 and 9 squared is 81. And then side to side is a distance of 12. Half of 12 is 6. So I would go 6 this way and 6 that way. So A is 6. And then A squared is 36. And that's my equation. Okay? All right, one left to do. It's a pretty short lesson, especially for a block. Number 5, last one. Suppose that I give you, a drawing of an ellipse. So let's go with 1, 2 in that direction and go 1, 2, 3, 4 in that direction. 1, 2, 3, 4. And let's suppose that we have a picture, and the book's pictures are much better than my ellipses. Well, that's actually a pretty good one. Ended on a high note. All right, so here's our ellipse, and the question is, find an equation. What's the equation of this graph? By the way, I didn't ask you, are ellipses functions? Yes or no? No, you're right. Why not? Because they don't pass the vertical line test, do they? All right, so we're not doing functions today, although they are fun. All right, so the equation would be x squared over something plus y squared over something equals 1. That's how I start my ellipses, because I know that's going to be like the skeleton outline of it, the general form. And I have to now fill these in. So a squared is going to go underneath x squared, and b squared is going to go underneath y squared. Well, from here to here is a distance of 4, and 4 squared is 16. And then up and down, this is a distance of 2, and 2 squared is 4. And that's it. All right, hope you enjoyed this presentation of ellipses. Friday's going to be a little bit harder, but we got this.